Hello, everybody. I will go over some problems from section 2.3 and 2.4 in this video as a supplement to my lecture video 2. Okay, so let's start with section 2.3. Both of these sections are actually applications though, from 2.3 and 2.4. Oh, by the way, since this is a supplement, so please do not continue watching this before you watch lecture video for 2.3 and 2.4. Okay, so watch that lecture video 2.3, 2.4 first, and then you watch this. Okay, now let's start. Question number 5 from section 2.3. I believe the question, the situation is right triangle, right angle at C. So for number 5, suppose we have a right triangle with right angle at C. Sketch the graph first. Okay, and then angle B, let's say angle B is here, 24.5 degrees. And side C, which is opposite of angle C, is 2.34 feet. The question is find lowercase a. Lowercase a is the opposite side of angle A. This is side A. Now then, to solve this problem, think about a trigonometric function that relates side A, which is the adjacent of 24.5 degrees, and hypotenuse 2.34. Okay, the trig function that relates these three quantities is cosine. Cosine B equals to A over C. Now we plug in numbers. Cosine 24.5 degrees equals to A over 2.34. So A is equal to 2.34 times cosine 24.5 degrees. Then you use your calculator. 2.34 cosine 24.5. I get 2.12931 feet. That's for our A. Again, in my class, round to 5 decimal places. Okay, let me rewrite these 3 here. It becomes clear. Okay, now that's for number 5. Number 9. With the same given that we have a right triangle, right angle at angle C. Let's say this is side A, this vertex A, angle A, and this is angle B. Now side A is 16, which is opposite of angle A. This is 16 centimeter. And side B is 26 centimeter. Okay. This is side B, opposite of angle B. And this is side A, opposite of angle A. Now, the question is find angle A. So find angle A. What relates this angle and side A and side B? That's tangent. Tangent A equals to side A over side B. Notice that A is an acute angle, right? A is 16 and side B is 26. Now, because A is an acute angle, then we can use tangent inverse. Okay, now then angle A will be tangent inverse of 16 over 26. I get 31.60750 degrees. Okay, now number 17 and number 21, the question is solve the triangle. Knowing that angle C is the right angle. Okay, so remember when we say solve the triangle, it means we need to get all three angles and three sides. Okay, but let's first start with sketching the triangle. So angle C is the right angle. Let's say this is angle A and this is angle B. It is given here that angle A, let me use slightly different color. Angle A is 32.6 degrees and side A is 43.4 inches. Okay, now let's put it in this kind of like diagram. Angle A, angle B, angle C. We know it's 90 degrees, right? And angle A here is given to be 32.6 degrees. We need to find side A. Oh, side A we know it's 43.4 inches. We need to find side B and also side C. Okay, now let's do the easy one first. We already know angle A, right? So angle B must be the complement. Then must add up to 90 degrees, right? Okay, so B, A plus B is equals to 90 degrees. So angle B is 90 degrees minus A, which is 90 degrees minus 32.6 degrees. That is 57.4 degrees. That one is easy. Right? 57.4. Don't forget the degrees. Okay, now then from there, let's say you want to find uh, side B. Find side B. Then you see what relates side B with angle A. We don't use angle B. Why? Because angle B is something we computed earlier, right? There's a chance that our B is incorrect. Okay, try to use the numbers that is given by the question. So to find side B, we see what relates side B, angle A, and side A. That's tangent, right? Tangent A equals to side A over B. Tangent 32.6 degrees equals to 43.4 over B. So B times tangent 32.6 degrees equals to 43.4. So B is equals to 43.4 over tangent 32.6 degrees. Okay, then we use our calculator. Side B, therefore, is myself more space. 43.4 divided by tangent 32.6. That is 67.86269 inches. Okay, the units is in inches, so we use inches. Okay. Finally, we want to find side C. Let me just squeeze that in here. Okay, side C. Again, we want to find side C here, but we will use the informations from the ones given by our textbook, by the question. We know this guy, we know this guy, right? So what relates 43.4, which is the opposite of 32.6 degrees, and the hypotenuse C? That is the sine function, right? So sine A equals to side A over hypotenuse C. Sine 32.6 degrees equals to 43.4 over C. So the same procedure with the tangent, the earlier question, multiply both sides by the LCD first, and then divide by the sine 32.6 degrees. Then from there, we will use calculator. Okay, 43.4 divided by sine 32.6 degrees. I get 80.55374 inches. Okay, that's for number 17. And so my B or my C just now is, let me fill this up so that I know I'm done with the question. 55374 inches. And then the B was 67 something. 67.86269 inches. Okay. So then number 21, similar situation. We have a right triangle at angle C. Let's say this is our right triangle. C, this is A, this is B, the B is 76 degrees, side C, which is the hypotenuse, is 5.8 feet. Okay, this is my angle A, unknown, side A, unknown, angle B, 76 degrees, side B, unknown. Angle C is given to be the right angle, 90 degrees. Side C is 5.8 feet. Now, then, since we know B, then we can find A easily, right? That's the complement, right? Angle A must be 90 degrees minus B, which is 90 degrees minus 76, that's 14 degrees. That's Mickey Mouse. Now then, how to find side A? How to find side A? And this is side A here, right? What relates side A, angle B, and hypotenuse? Now, this is not sine. This is not sine. Sine A is A over hypotenuse, but we don't know angle A. We know angle B instead. So what relates angle B and A and hypotenuse? That's cosine, not sine. Okay, cosine B equals to A over hypotenuse. Cosine 76 degrees equals to A over 5.8. So the A is equal to 5.8 cosine 76 degrees. Okay, so 5.8 cosine 76 degrees is 1.40315 feet. Okay, 1.40315 feet. Now, then the next one, how do we find side B? Where's the coloring here? To find side B, what relates side B and 76 degrees and hypotenuse? That's sine B. Sine B equals to side B over hypotenuse C. Sine 76 degrees equals to B over 5.8. Okay, it is 5.8 times sine 76 degrees. 5.8 sine 76 is 5.62772. Okay, 5.62772. Therefore, we solve this triangle already. Okay, let's do more problem. More problems. Number 29. Now here they don't give us the angle. Well, beside angle C, right? Let me just continue from here. So we have side A. We need to find angle A. We have side C. And angle C is known to be 90 degrees. We need to find side B and angle B. Okay, now let's draw the triangle first so that we have a better view of what we need to do. What we know, what we don't know. Okay, remember a picture tells 1,000 words, right? A lot of you says that you are a visual person. Now then, if you are a visual person, try to visualize that by sketching the graph yourself. Okay, side A here, opposite of vertex A, is 2.75 centimeter. And side C is 4.05 centimeter. Now, how to find which one is easier to do here? Actually, we can do each one of them quite easily. Let's see. So, for example, if I want to find angle A, what relates side A and side C with angle A? That's sine A. Sine A equals to A over C, right? And sine A equals to 2.75 over 4.05. Now, and side angle A is, apparently you can see there, is an acute angle. So we can use sine inverse. Sine inverse of 2.75 over 4.05 is sine inverse. I use my calculator. I get A is equal to 42.76651 degrees. Now, the nice thing is A and B are complementaries. So once you know A, we can find B by computing the complement. Okay, so angle B will be 90 degrees minus 42.76651 degrees. That is 47.23349 degrees. Okay, so we have found side angle A. Angle A, that is 42.76651 degrees. And then we have found angle B also, which is 47.23349 degrees. Now, how do we find side B? Now, notice that we have two sides of the right triangle. Now, once you have two sides, you can use that to find the third side. Okay, let me do it here. So side B, A squared plus B squared equals to C squared. Okay, A squared is 2.75 squared plus B squared equals to 4.05 squared. squared equals to 4.05 squared minus 2.75 squared. Okay, so 4.05 squared minus 2.75 squared, I get 8.84, whose square root is, I think this is, this is 2.97321 centimeter. Okay. This is 2.97321 centimeter. Okay, that's for number 29. Okay, let's go on with number 33. The question for this number 33 is find the measure of angle A. Find angle A, this one here. What is the angle here? Okay, now this triangle consists of two right triangles. Let me just call it the angle on the triangle on the left, right? Suppose I call this so on the left we have, this is 4.0, this is angle A, and this is a right angle. Okay, and the right triangle on the right hand side, we have, this is 30 degrees and this is 6.0. Notice that both of these two right triangles actually share the same height. I mean, you take a look on the picture, right? This is that in that picture, basically these two right triangles being stick together, right? So they share the same height. Okay. Now our plan is this: we can use this 6.0 and 30 degrees to find the height, which is the height of this thing, and using that height and 4.0, we find angle A. That's our plan. Okay, now let's start. Let's start. So in this triangle here, notice that sine 30 degrees equals to h over 6.0. Now we know sine 30 degrees, it happens to be a special angle, right? So sine 30 degree, we know is 1/2. If it is not a special angle, then you just use calculator. Okay. However, because right now we already supposed to memorize the value of sine 30 degrees, then we use the exact value. Okay, so the height h will be 1/2 times 6.0, which is 3. Okay, now then we go on to this triangle. We go on to this triangle. Notice what relates angle A and the height h, which is 3, and 4.0. That's a sine again. But sine A here, A is the one we don't know, right? 3 over 4. And clearly, from what you can see, angle A is an acute angle. So sine A equals to 3/4 implies A equals to sine inverse of 3/4. Then you use your calculator. Sine inverse of 3 divided by 4 is 48.59038 degrees. Okay, that's for our question number 33. Let's go on. I think we have 3 more questions, but these 3 questions actually are considerably harder questions. Okay, be patient. Okay, the more practice you have, the more mature you are. But keep in mind, when you study from my supplemental lecture videos, I strongly suggest you to follow it in writing. In this way, you watch my explanation first, and then you stop the video, try to do it on your own, and not only to get the same answer, but also try to learn to show your work in a systematic way. Okay, number 35. We have this diagram here where angle A is 31 degrees. So if you already have the picture, fill that up. Okay, this way then you have a better view of the situation. That one is 31 degrees. The radius is 12. So this is 12. Oh, this is also radius, right? This is also 12. Find x. Now, what relates 31 degrees and this guy and x? But x is actually part of that. X is actually part of these, right? Part of these. You see what I mean? This is our x. This is our x. Okay. And this is our r. Now, the hypotenuse is r plus x. Okay. Our hypotenuse is r plus x. So, okay, so sine 31 degrees equals to the opposite 12 over the hypotenuse 12 plus x. Now we can use this to solve for our x. Okay, so 12 plus x times sine 31 degrees equals to 12. 12 plus x equals to 12 over sine 31 degrees. We can compute that now. And then later on, after this, we will divide. I will subtract by 12. I get 23.29925. So x is equals to subtract by 12, that will be 11.29925. Not too hard, right? It's not too hard. But you need to be able to look at that graph and interpret the situation. Okay, number 43. I think this question will be harder. Angle A is 41 degrees. So angle A here is 41 degrees. BDC. BDC. So this angle here, that is 58 degrees. This is 58 degrees and AB is 18. The question is find x and then y. Notice that x, we actually have two right triangles here. The first right triangle is this one, the small one. Let's call it a small triangle. Right? And then we have the big triangle. The big right triangle is this one here. Okay, now notice that the big right triangle and the small right triangles, both of them share the common side height, the h. Okay, now, so what we can plan to do is, let's take a look first on the big triangle where we have that 18. Right? This is 18. This is 41 degrees. This is the height. Let's find the height first. Then we can use that height to find the x. Okay. Actually, once we get the height, we can also find this guy here, AC. Okay, which is x plus y. Okay, let's do that first. So the height equals to, so sine 41 degrees equals to height over 18. So the height is 18 times sine 41 degrees. Using calculator, I get 18 sine 41 give me 11.80906. That's the height. Okay, now We can also use this 41 degrees and 18 to find the length of AC, right? The length of AC. The length of AC, which is actually x plus y, right? And length of AC relates to 18 by cosine of 41 degrees. Cosine of 41 degrees equals to x plus y over 18. So x plus y equals to 18 cosine 41 degrees. We don't know x yet, we don't know y yet, but we know the sum. We get 13.58477. So you see, once you get to higher education, notice that some problems you cannot just do it in one single step and you get the answer. No, that's not that cheap. We are not that cheap. Okay, now then let's take a look on the smaller right triangle. We know the angle here is 58 degrees. Okay, and this is h here, which is 11.80906. And we can use that now to find x. Okay, and they are related by tangent, right? Tangent 58 degrees equals to 11.80906 over x. So x tangent 58 degrees equals to that. And x is equals to 11.80906 over tangent 58 degrees. What's that? 11.80906 divided by tangent 58 degrees. That is 7.37912. That's our x. Now, notice that even if you look back here, once you get your x now, and we know the sum here, right? The sum here, maybe I use another color. The sum, the total length here is the same to this. Okay. Now we know the x part, then the y part can be computed by subtracting 13.58477 by x. Okay, so let's continue here. We know that x plus y is equals to 13.58477, right? So y is equals to 13.58477 minus x, which is 7.37912. Okay, then I'll use my calculator. I get y equals to 6.20565. Okay, that's our x and then the y. So you see, you break down this figure first into right triangles, okay, and see what do they have in common. Try to find that first. Set up the equation maybe, okay. That's for this question. Now let's go on with the last question from this section. Number 47. Well, this seems to be hard. I don't know. Okay. We know that angle A is 43 degrees from the question, right? And then BDC is 57 degrees. Side Y is 11. Find x. Oh, okay. Seems like we really need to redraw these two triangles. So the small one first. Small one first. This is C, this is X, this is 57 degrees, and this is H. The bigger triangle, this is 43 degrees, right angle here. This is the height. This is 11 plus X. Notice that they share common H, right? So we will relate H and X and the angles. On the smaller triangle, we have tangent 57 degrees equals to H over X, while on the bigger triangle, tangent 43 degrees equals to H over 11 plus X. Solve for H for both of them and equate them. So H from the first triangle, H equals to X times tangent 57 degrees. From the second triangle, H equals to 11 plus X times tangent 43 degrees. Now, both of them equal to H, right? So we can equate them. We can set them equal to each other. X tangent 57 degrees equals to 11 plus X times tangent 43 degrees. Okay, now let me give you some motivation first. Why we learn this. Now imagine you have a tree. Imagine you have a tree. Okay, now which we don't know the height. Okay, we don't know the height. But then Thomas stand here. You find the angle of elevation is to be 43 degrees. And you stand closer to the tree and find the angle of elevation is 57 degrees. And we know our distance to each other between me and you is 11 feet, let's say. Can we use these informations that the distance between us to be 11 feet and your angle of elevation is 57, my angle of elevation is 43. Okay? Now, if we know this, then we can find the x here. And notice that once we know the x, we can find the height of this tree. Okay, without climbing there. It's nice, right? Okay, so that's the motivation. So let's find the x first, which is what this question wants us to do. Okay, I will distribute the right-hand side. So I get x tangent 57 degrees equals to 11 tangent 43 degrees plus x times tangent 43 degrees. Now, tangent 43 degrees is just a number, okay, times x, right? So I will move x tangent 43 degrees to the left-hand side. So I subtract both sides by x tangent 43 degrees. Factor the x. And then after this, you can use calculator already, okay, even though I will not, to avoid rounding error, but you actually can. Let me just do it. Tangent 57 degrees subtracted by tangent 43 degrees. I get x times 0.6073499 equals to 11 times tangent 43 degrees. So x is equal to 11 Let me compute this. What is 11 times tangent 43 degrees? 11 tangent 43 degrees is 10.257666. So x is 10.257666 over 0.6073499. Notice I rounded to more than 5 decimal places. Okay. Why? Because my final answer later on will be rounded to 5 decimal places, right? Now, before then, try your best not to round anything yet. Okay. We don't know how much the compounding rounding errors can happen, so we try not to round it yet. This is what I get. This is the x. Okay, which is the answer that we need right now. But suppose you go back to earlier question, suppose your distance and my distance standing on the same side in line on the same side of a tree is 11 feet. My angle of elevation is 43 degrees. Your angle of elevation is 57 degrees. Can we use this information to find the height of this tree? The answer is yes, because from here we get the x. Then the height will be, notice from the smaller triangle. From the smaller triangle. Okay. Tangent 57 degrees equals to the height over x, right? Right? Look at this triangle here. This one. Okay. So the height is x times tangent 57 degrees, which is 16.8892 tangent 57 degrees. Whatever I have on my calculator right now, multiplied by tangent 57 degrees, I get the height of the trees, or in this case, the height of this, the common height of this triangle will be 26.00712. If you round it to the nearest unit, you will call that 26. Okay, this is for the supplemental questions we do from this section 2.3. Let me take a little break and by pausing the videos. I'll come back after some little break. Okay, 2.4 supplement. Question number 1. Two equal sides of an isosceles triangle. Oh, isosceles triangle. Let's draw it first. Isosceles triangle approximately like this, right? Okay, isosceles means they have two congruent sides. These two sides are congruent in this case. Now, the two equal sides of an isosceles triangle are each 42 centimeters. Let's say this is 42 centimeters, and this is also 42 centimeters. If the base measures 32 centimeters, find the height and the measure of the two equal angles. So isosceles triangles, if two sides are congruent, if two sides of a triangle are congruent, then the opposite angles must be congruent. Okay, we actually learned that in geometry. Unfortunately, at West LA College, we don't have geometry class before as a prerequisite of trigonometry. So I need to supply you that information. But we know that these two angles will be congruent. Okay, and find the height. This is the height. Notice that the height, therefore, will bisect this isosceles triangle into two right triangles. These are the two right triangles I'm talking about. One right triangle here and another congruent one on the right hand side. Okay. Now, Because they are congruent, then we can say that this side here must be half of that 32. Is it right? This must be, therefore, this must be half of that 32 must be 16 centimeter. Okay. Now, use that to confine the height. Notice that we have that right triangle, right, where the hypotenuse is 42 centimeters and the side, one of the leg is 16 centimeters. So what is the height? Which is the height of this isosceles triangle? Now this height is also called altitude. Okay, we will use Pythagorean theorem. So 16 squared plus the height squared equals to 42 squared. Height squared equals to 42 squared minus 16 squared. That is, I use my calculator. That is 1508, 1508. So the height is 38.83298 centimeter. Okay, now how about now next thing we need to do is to find the angle. What relates this angle here with 16 and 42? Cosine, right? So cosine of that angle, let's call that angle A. Cosine of angle A equals to 16 over 42. Angle A is an acute angle, so we can safely use inverse cosine. So A is equal to cosine inverse of 16 over 42. That is 67.60731 degrees. Okay, that's for number 1 from this section 2.4. Let's go on. Question number 5. Length of an escalator. How long should an escalator be if it is to make an angle of 33 degrees? Let's sketch the graph. So it needs to make 33 degrees angle. Let's say this is the escalator. Okay, now the angle is 33 degrees and carry people a vertical distance 21 feet between floors. So elevator is to bring you from one floor to the next floor, right? So let's say this is the next floor here. This is the lower floor. They tell us the distance between floor to be 21 feet. Now, the question is, what is the length of the escalator? Let's call this X. Now, then what relates that 21 feet, 33 degrees, and X? That's sine, right? Sine 33 degrees equals to 21 over X, right? So X sine 33 degrees equals to 21. So X equals to 21 over sine 33 degrees. That is 38.55765. Okay, that's for number 5. I think this question is easy, huh? It's just like simply because it's word problems, you need to translate that first, draw the picture. What do you expect that to be? Okay, number 11. Angle of depression. Good thing they give us the picture here. A person standing 150 centimeters from a mirror notices that the angle of depression from his eyes to the bottom of the mirror is 12. So take a look on this triangle here. This triangle here. the angle of depression is 12. Okay, and while the angle of elevation to the top of the mirror is 11 degrees. Now the question is, find the vertical dimension of the mirror. Vertical dimension. So imagine this. This is the horizontal. This is the horizontal, right? Okay, this is 150 centimeter. Okay, the angle of depression is 12 degrees. So later on, using that, we can find the length here. Like, let's call that x. Meanwhile, the angle of elevation from the eyes is 11 degrees. This is 11 degrees. Now, we can use that to find the y, right? Now, x plus y will be the dimension that we're looking for. Okay, so think of this like we break it up into two triangles. Now, what relates, let's go back. What relates x and 12 degrees and 150 centimeters? That's tangent. Tangent 12 degrees equals to x over 150 centimeters. Okay, so x is equal to 150 tangent 12 degrees. Okay, likewise, for the angle of elevation, tangent of 11 degrees equals to y over 150 centimeters. So y equals to 150 tangent 11 degrees. Okay. Now then I will use calculator for both. That's 150 times tangent 12. That is 31.88348 centimeter, while 150 centimeters times tangent 11 degrees is 29 something. So the dimension will be the vertical dimension will be x plus y. Okay, which is 31.88348 plus 29.1575. And that will be, oops, hold on. That will be plus 3, I get 61 something. So x plus y, which is the dimension, will be 61.04053 centimeter. Of course, if you look at the back of our book, our textbook will just say this is 61 centimeter. Okay. Let's go on. Next question. This section, a lot of application, huh? Okay, we have this picture here, the height of a door. From a point on the floor, the angle of elevation to the top of the door is 47 degrees. So it is referring to this triangle here. Okay, which if I redraw, okay, this is 47 degrees. Yeah, of course, the door is supposed to be perpendicular to the ground, right? Okay, and the height is x. Now, if the ceiling, oh, hold on, that's 47 degrees, right? While the angle of elevation to the ceiling above the door is 59 degrees. It is referring to this picture here. In this picture, referring to this right triangle. It refers to that right triangles. This is 59 degrees. This is 9.8 feet. And notice that there, the distance from the door, I'm referring to this distance here. The distance from the door of these two triangles are the same, right? The distance from the door are the same. Okay, let's call that y for now. Let's call that y for now. Okay, now what we will need to do is to find x, right? Let's come up with a plan. Notice that again, they share the common y. Using the larger triangle, you can find the y using tangent. And we use that y to find x in the small triangle. Does it sound like a good plan? Okay, so from this triangle here, we see tangent 59 degrees equals to 9.8 over y. So y is equal to 9.8. You multiply both sides by y and then divide by tangent 59 degrees, right? So y is equal to 9.8 divided by tangent 59 degrees. Oops, sorry, 9.8 divided by tangent 59 degrees. I get 5.88843 feet. Now, I will use this y in this smaller triangle next. Okay, tangent 47 degrees equals to x over y. But we know the y. Five 5.88843 feet. So x will then be that 5.88843 times tangent 47 degrees. Everything after that is using calculator. Okay, 5.88843 times tangent 47 degrees. X is equal to 6.31457 feet. Okay, that's for this question here. Basically, again, we will break up the triangles into two right triangles and see what common side do they have, right? And then you use the result from one triangle, apply that in to the other triangle for the common side in this case. Okay, next. Number 23. Let me see how many questions, how many more. That's the last one. Okay, number 23. This is the one I told you earlier. From 2.3 supplement, let's see. This one. Do you remember this? Right? That's basically the same question. Okay. So what happened is there's a couple standing on the same side of a tower, and the distance between these two people is 33 feet. Now, the angle of elevation for the lady, which is closer to tower, is 47 degrees 30 minutes, which is 47.5 degrees. Okay, this is X, this is H. Notice that these two triangles share common height. So we will use the height as the bridge between these two triangles. Okay, this is the height here. Okay, and this is 42 degrees and 10 minutes. That's 42, 10 minutes. Okay, 10 minutes equals to 10 over 60 degrees. that is 0.16667 degrees. So this is 42.16667 degrees. Now, the adjacent side, however, is 33 feet plus that x. Do you see that? Maybe I use slightly different color so that you see what I mean. This is the x, right? This is the x here. This is the x here, plus 33 feet. Okay, this is 33 feet, and this is the x. Okay, now they share common height. That will be our bridge. The first triangle, tangent 47.5 degrees equals to h over x. The bigger triangle, tangent 42.16667 degrees equals to h over 33 plus x. So we solve for h and then we set them equal to each other. Now don't compute this too early though. Don't change this tangent 47.5 degrees too early. This is 33 plus x times tangent 42.16667 degrees. Now I will set them equals to each other because both of them just the height, right? So x times tangent 47.5 degrees equals to 33 plus x times tangent of 42.16667 degrees. Distribute the tangent 42.16667 degrees. I get 33 tangent plus x times tangent equals to x tangent 47.5 degrees. Okay, subtract both sides by x tangent 42.166. Degrees equals to 33 tangent 42.16667 degrees. This is x times tangent 47.5 degrees minus tangent 42.16667 degrees equals to 33 tangent 42.16667 degrees. Okay, now calculator time. Tangent 47.5 minus tangent 42.16667. I get x times 0.1856233. Notice that I rounded to more than 5 decimal places. The reason is because later on we'll round to 5 decimal places, right? Okay, this is 42.16667. On the right hand side, I get 29.887611. So x itself is that 29 something divided by 0.1856233. 161.01 something. 161.01218 feet. I believe if you check with the back of our textbook, the answer will be 161 feet. Okay, or maybe 161.0 feet. I think these are the questions which are representative to what you need to know from section 2.4. Okay, that's for this supplement for this section 2.3 and 2.4.